Well, good morning, sir.
Morning.
I'm excited to get this story. I talked to Judd yesterday. He goes, "Oh, Andy's like, he's awesome. He's a true Geo." And I went, "Huh? He's one of the true crew. All right." So tell me a little bit. Let's just start with why or how you got into the position of being a field trip leader at one of the most, in my opinion, oil and gas related in America, most prestigious geologic events of the year. Man, the WTGS Fall Symposium
Yeah, dude,
is
it's exciting. So yeah, that it's an interesting story. So the background here, I had for a number of years, or a couple of years, I had led some internal core workshops and helped out with some field trips within Chevron. And Holly Warmke, who was then
yeah,
WTGS president at in 2020, 2019 to 2020,
that's
had
right.
asked me in early 2020 to see if they could help out, if I could help out with the planning the field trip for WTGS Fall Symposium that year. Of course, she literally asked me, I think it was maybe the third week in February of 2020. So within less than a month, COVID hit and everything was canceled. And so anyway, yeah, so I was living in Midland at that time. I'd moved out there. I'd worked in Chevron for a couple of years in Houston, and then had moved out there to Midland in 2018 to work on Western Delaware Basin,
Okay.
drilling and operation support. And so anyway, yeah, so COVID hit, and I'm a single guy living in a house I don't own with roommates, and then I'd been asked to lead this field trip, and to which I had kind of carte blanche authority to go wherever. And then it's like, well, I'm a single young guy living in Midland. Might as well knock myself out now because I don't know when or if this thing is actually going to happen. And so,
Awesome, man.
so I had gotten curious. We had been drilling in the Western Delaware Basin deep disposal wells targeting the Silurian, so the
Really?
Silurian and Ordovician, so your Riston group and Fusselman and Montoya and all those
Okay.
carbonate strata that
Oh
were
yeah,
targeted at the
hydrothermal
time.
carbonates.
Yeah, and they're ancient carbonates. They're part of that big, similar environment to the Great Ordovician Carbonate Bank that was in the Lower Ordovician during the Ellenberger time. And so broad ramp that or broad platform that is covering the Laurentian Craton uh over 1,000 miles wide. So really, interesting rocks, but complicated.
This is between the Silurian and Ordovician timeline.
Yeah. So you're running from so your key formations that you care about in here are, well, first off, you have your Ellenberger,
Right.
and in the surface in far west Texas, that's called the El Paso group, and that's your lower Ordovician. But in the
That's it. That
Delaware,
is that the one that's exposed in the Franklin Mountains,
correct.
the
That
southern Franklin Mountains.
so yeah, that's the one that's along there
Oh,
on
baby.
Scenic Drive and the Southern Franklin
Oh
Mountains.
man, I love
Yeah,
that place.
where you can see you see the collapse features on
Big
McElligin Canyon
time.
Road, and then you have the Scenic Drive exposure where you see the entire zone exposed.
Yep.
So that's the lower Ordovician. So that goes from the Great Unconformity, where you're sitting on Precambrian Thunderbird Group igneous rocks,
Right.
up to, and then that you have that initial transgression in the Ordovician. Okay, so lower Ordovician, but for Delaware Basin disposal drilling, there was a special rule from the Railroad Commission you couldn't dispose into the Ellenberger. So although that was targeted in the Midland Basin, we weren't drilling all the way down to it in the Delaware Basin. And there's been a lot more work done historically on the outcrop of the Ellenberger group. But
Okay.
then you get up above that into you have the upper Ordovician, where you have the Montoya group, um, and then which has had some extensive outcrop work done in the last 10 15 years by Mike Pope, who's now at Texas A&M.
I've heard
um,
that name. Do you have a cross section that you can throw up so we can
I
see?
can. um,
Nice.
yeah, let's take a look at, so this is of course the famous WTGS 1984 cross section, just a snippet of part of it, right?
Right.
um, so this is from oops, below all your, so this
Ah,
is just zoomed in on the Central Basin uplift and to the west of that, right? So you're going, the city of Midland is a little bit to the east of where the screen ends, right? And then you have your Central Basin uplift. You go across the whole Delaware Basin. So you've got, Kermit and Orla and all those cities out in here. You go out west where we were drilling wells a few years ago targeting this. And right, you have your Castile, your evaporites, then you have your Delaware Mountains group clastics, and then you have your wolf camps in Bone Springs, right? They're all your unconventional reservoirs. And then underneath all of that is your Fusselman. If you're in the right part of the basin, you have Devonian above that. And then Montoya Group and Ellenberger. And the key takeaway from this is that these outcrops are continuous and they are of similar facies in the outcrop belt. We go all the way west to the Franklin Mountains where they're exposed. There's a lot of vertical exaggeration in this cross section, so that apparent thinning is just kind of due to distortion there, but they're actually quite similar in thickness. And what's really cool is that if we look right here, so I've got gross thickness contours of the entire Ordovician to Devonian interval in the subsurface and the outcrop. Here's our Permian Basin present day outlines with producing gas, oil, and water disposal wells that are targeting the upper Devonian to upper Ordovician zone. Okay. And what's cool is that we actually see within the outcrop area, the outcrops are in blue here, very similar changes in thickness and in facies to what you would see if you cut a cross section in the kind of Delaware Basin part that's been very active for water disposal in the past few years.
Hmm.
So that's pretty exciting. But yeah, going back to the main formations of interest, right? You have your Ellenberger group, which is called El Paso group and outcrop. So here's the subsurface, here's the surface, and the far West Texas surface. Then you have your Montoya group. Your Simpson group is absent in the Franklins. You get a little bit down of it in Jeff Bezos land and the Beach and Baylor Mountains. And then you have your Fusselman, okay? And the terminology gets confusing here because you heard me throw the term Risting group around.
Mm-hmm.
And then I start talking about Fusselman and outcrop, and that's because the Risting group is a subsurface term. So that was defined based on subsurface log data and published back in the 70s. But more recent conidant data, historically, they only mapped what they called the Fusselman and outcrop. Conidant data by Barrick and Meyer starting in the 1990s and a couple of subsequent publications indicated that the upper part of the Fusselman and outcrop is actually age equivalent to the Risting group of the subsurface. So the stuff that we get to look at in the field, we do a little bit of Ellenberger. I wish we had more time to do more of it, but again, there's a lot of material out there. But then the stuff that I did during COVID was remeasuring these sections, a little bit of the Montoya and then especially of the Fusselman, because
Okay.
it's just not as well understood.
Right on. Okay. So the Ordovician to Silurian. Ordovician to
Mm-hmm.
Silurian. Okay, yeah. Major
So yeah, you're looking
tectonic.
at, so what's interesting about these intervals, and of course why I got so interested in this was, we drilled these deep wells down here, and there was a lot of assumptions that went in. Water disposal, as y'all know, is a huge topic
Right.
in the unconventionals, and that kind of the whole premise of the Permian Basin is risked on us finding enough pore space to put the associated water away from
Right.
these zones. And so, one of our plans early on was to avoid creating drilling hazards for ourselves. We want to put it way down below and stuff we're not going to drill through, right? So we put it down here. But what's interesting, you can see from the porosity log and the sonic log on here, this is a low porosity system. I mean, you're talking about, 1 to 2% matrix porosity generally. So
So
a
you need
lot of,
fractures.
right, 100. So you're talking fracture, vuggy porosity system. So what, the engineers thought was going to be a very predictable system, right, ended up being very erratic. And we
Wow.
also saw some strange features in the logs. And, as the geo side, we were challenged to really say what's pay, what's not pay. There were things that we looked at and we didn't understand what they were. And
You're talking
so
lower Fusselman is where you're seeing these features and trying to.
Risting
Oh,
Groot,
all of it.
Fusselman,
All of it.
yeah. So that was so that was, and there were, of course, that whole interval. When you look at the old wells, there's all sorts of interesting things. But like I said, a lot more publication work has been done on the Ellenberger and Montoya, and the Fusselman there was less. So yeah, so
So the regional tectonic story between Ordovish and Silurian is you got tectonic orogenic event that's going east directed,
mhm.
and then bang, the Antler Acadian comes in at that Silurian, and it's going the opposite way. So you got in this transition like crazy like regional tectonics are like fundamentally changing across
Right.
this boundary.
And they're probably responsible for generating a lot of the clastics that you get in the Simpson group and the subsurface as those events start to happen. And then you obviously get the other interesting part of this section, right, is that those are driving, you're talking about global scale tectonic events that
Yeah.
are driving these time gaps, these unconformities here. And right in this interval between, and what's fun about going to this part of the section, right, is just looking at this lower Paleozoic section. So, which is very similar. It's almost identical to what we see in a lot of the Permian Basin subsurface in the far west Texas outcrop, that you pass over nearly 100, basically 100 million years of geologic time. And you've got some of these unconformities, right, which are sloth scale supersequence events. So those are globally correlative unconformity events, which are driven, we know those first order things are driven by tectonics.
Yeah.
So you're talking about,
Amazing.
these exposure surfaces. Some of these exposure surfaces are over 10 million years, and the karstification and history of uplift that happened in those times is absolutely essential to creating the pore system, that you see in these intervals, and likely why you want to, that there's often you see a lot of vugging and stuff like that near these surfaces, right? As you would expect, because it
This
was
is
above
cool.
ground for 10 million years. So
What's the structure story have? So the porosity permeability is not that great, but there's got to be fracture permeability and all this stuff.
100%. So, I to talking to the subsurface data, right? There's probably a lot that is maybe still proprietary or still a lot of,
Sure.
company stuff. But yeah, it's just looking at that, right? The fact that, people have put, just from public data, that people have put a lot of water away in these systems,
Yeah.
and it's got 1 to 2% matrix porosity, right? I mean,
Right.
you're dealing with a tectonically fractured and vuggy system. So this interval has seen everything that's happened in the Permian Basin to Bosa Basin history, right? So you have
Yeah.
those, the all the way from the ancestral Rockies events, where it's at the outer fringe of it, and then getting to the things that created the macro structures that we see in our Permian Basin deep fields. So when we get into the later events, the the Laramide and Basin and Range, which form the macro structures, that we see around here, but also the Marathon Ouachita stuff that uplifted the Central Basin uplift in the Pennsylvanian time period. So
Right
yeah,
after this. Yeah.
so you have, so yeah, this stuff has seen some things. Uh, so it's, and so yeah, 100% that. And when you talk about the lack of predictivity in these for reservoirs, right? Um, that's largely why, because if you're tapping these things with a vertical well, whether or not how many of those fracture sets, so you're going to have distinct fracture sets that are associated with each of these events. Um, how many of those you happen to tap into, right, is going to drive your well performance. And it also, when you start thinking about, performance versus time, if you see the wells fill up, if you see
Mm.
communication over large distances, we might speculate that that could be due to tapping into to some of those systems. So it's a complex, it's a complicated system, but we also know we have a vugging story, right? So you have a vug and karstification.
How big are these buggy? Like
So
yeah.
I'm glad you asked that, because we have records from some of these older wells that drilled in this area. You're talking bit trips on the order of 10 feet, or bit drops on the order of 10 feet at 12,000 feet deep, right? So like, so you're talking about a cavern, like a
Yeah,
stand-up
dude.
cavern that's preserved
You could put
at
a
this, and
human
that's
down.
one of the fun things we get to see on the field trip. Is we spend a little bit of time in the Southern Franklins, but we'll go to the Northern Franklins, and um, we'll get to see a cave in the Fusselman that's surrounded by a
Wow.
lot of vuggy porosity, and then you get to talk about, well, how would these systems interplay with each other,
Is
and you
that the
actually,
one? Go ahead. Go ahead.
uh,
Go ahead.
but that's how you actually see things like that in some of the old drill stem test data when they ran these reservoirs of that you would they would when you look at the old pressure buildup curves, these things would pressurize very quickly and appear to level out, and then they keep running it a little longer, and all of a sudden it'd pop up again and then level out again and keep going, and then it'd pop up again, and some of them would repeat like the same number of those stages on both the initial and the final buildup. So you're
Is
looking
it?
at a thing where you've got large vugs and caverns connected by maybe fractures that are poorly, and it's like you deplete one of the reservoirs, and then the pressure differential gets up enough that the fluid squirts through, you know.
Whoa.
So so yeah, these are complicated systems. Then you've got places like Dollarhide Field,
The
where at
dollar hide.
WTGS Symposium around the year 2000, Unocal had collected a core through the Fusselman and Montoya there that they
In the
since
Midland
don't.
Basin?
That is on the western side of the Central Basin uplift.
Okay.
So going into the New Mexico, like Eddy County corner of the
So like
Central Bay.
Andrews or Borden or something, or what county is that in the it's
Oh,
still in
that doesn't.
Texas or it's in Eddy?
It's in Eddy.
Oh, they did this in Eddy. Okay.
Yeah, so they collected this core in Eddy on the west edge of the Central Basin uplift. Uh, and so they had published on it back around the year 2000, and then donated the core to the BG. And if you actually read the BG slash APG Memoir 118, the Permian Basin 2 volume set that we all have, um, that they they then looked at that for both their sections on the Wriston group, on the Fusselman and the Montoya. But there's cavern fill porosity in that field. Um, so sometimes you could actually get these, caverns collapse and, fill with detrital material or,
Yeah.
just fractured stuff. And it would, so yeah, when you speculate about the different mechanisms that could be at play in here, it is why, it really behooves you to understand what you can glean out of the outcrops in 3D, because your subsurface data tends to be few and far between.
Right.
There's not a
Yeah.
lot of cores. The logs are often very old, and they're often of low quality because due to those fractures and due to those bugs, right, you
Can't
have
even
a lot of drilling hazards in
drilling
there.
hazards. Yeah, the
Mhm.
tools can't even read through those fractures very well. Yeah, it's all jacked up. Wow. And that so the cave that you're going to take all these folks to is that you see the fault? Is that what you were talking about in the write up? You wrote a little 2-pager on this event that's coming
Oh
up. Is
yeah,
that?
so that's two different things. So
Oh, it is.
yeah, so we'll go. Let's take a look at some of the outcrop maps. Okay, so the Southern Franklin Mountains that we were just talking about, right? That's
Yeah.
actually a little bit off of this map right down here. So the
Okay.
um,
Gosh.
scenic drive goes right along here. We'll drive past that. We'll go up McKelligan Canyon Road and look at
Oh, we
the
will.
collapse features here. Yeah,
Oh, you will.
um,
You're going to stop there.
yeah.
Oh,
Um,
dude, it's so good.
Those are amazing.
So,
Yeah. And
oh,
they're our best analogs for a lot of these features we see in seismic, in the subsurface. Of course, we see things like this in the Midland Basin.
when
There's been a lot of publications on the ones in the Fort Worth Basin.
so when I was there in 2016, we had a field trip leader. I think it was Pope. I think it was that guy.
Mhm.
Um, and he took us up. What's the name of the canyon?
McKelligan Canyon.
McKellican. And
That's the one with that's the main one that you get, that like the road goes up, like you can drive up it. And then there's a,
is that where the
um,
lift's at? Is that where the shuttle that takes you to the top of the mountain is?
yeah, yeah, used to
Okay.
be anyway. They,
We we got off that trail and we went north a little ways, and then we hit a nice walking trail that went up to the bottom of this big karsted What's that canyon called? And there's like a
So
cave.
there's Fusselman and there's Fusselman Canyon, Crazy Cat Canyon,
I'd
a
have to
couple
go
of other
back and
ones, but those were not, we're not actually going to walk up to them, so we'll see them from the road.
right on.
But because of the focus of, since unfortunately in that lower section, the Fusselman actually gets faulted out down there.
Okay.
So I spent most of my time in the field looking at these 4 localities that are on these maps.
Okay.
And that's where we kind of have new data, that's different. So the but yeah, we will at least see those from the main road up McKelligon Canyon.
Right
Um,
on.
so then, but yeah, then we go up to these areas. So I've got on here contours of the Fusselman. This is from Kotlowski and Prey in the 1960s, and then these are the sections that I have measured right now. So this was, like I said, that was a fun project. So yeah, so starting in COVID, I was like, well, might as well do this thing. So I spent, over the past few years, I've been adding up the time. It's almost 3.5 months cumulatively that I've spent out here.
Wow.
So yeah,
You,
mostly at these places. And of course, I was working full time the whole time. Now our drilling slowed down during COVID, but
okay.
I had and once I broke down and bought my handheld gamma ray scintillometer, which until I got moved back to Houston and bought a house was the most valuable object that I owned. But uh but was but anyway, I was like, well, I'm committed to this now, so I'm gonna, so yeah, so I was going out vacations, and for a while there, almost every weekend or every other weekend in Midland. So I just had my camping gear in my car, and when we get our 980 Fridays, I would work till usually kind of late on Thursday to make sure I got all my emails out, and then just get in there and skedaddle out to the
Man,
mountains,
living
get there
it.
sometime around midnight, sleep on the outcrop, hike a couple miles in the morning. And
Man.
then yeah, it was, oh man,
Eesh.
it was spectacular, but yeah, a little bit PTSD'd over it some, but but yeah, it was this, but this stuff, what we generated. So right, this map here, it's that map is the red area, right, the red
Okay.
dashed area right here, and so then these are the cross sections, and this is all the data that I got. So this shows the entire, so you have the Fusselman, which is the upper Ordovician to the lower Devonian. These are the 3 lithostratigraphic members are called the Crazy Cat, the Flag Hill, and the Chamberino in outcrop. And then you have the Montoya, which the Montoya, although that was not the main focus of study, I spent some time with it too because I wanted to test these kind of my little toys I was measuring on the rocks to see if they could identify these sequence stratigraphically significant surfaces that Dr. Pope had mapped in his outcrop. So, and the Montoya outcrop, of course, is continuous with the Fusselman outcrop. Um, so, major unconformities in the squiggly line. The actual M1 to M2 surfaces on here are third order unconformities, or third order sequence boundaries. But what we've got here, right, is total gamma ray, Lieb rebound here, which is basically rock hardness, okay? Potassium, uranium, and thorium, reactivity with dilute HCl. So the limestone intervals are shaded in blue. And then bed thickness, a facies description, which is, I prettied this up for the Fusselman part. The key here is the reds are above ramp crest, the blues are below ramp crest, the grays are massive mudstone or massive Dola mudstone that you can't
How'd
really
you
tell.
how'd you
And
make the
then
different what'd you use to make the differentiation of the red versus the blue?
So what we can get into that if we want to, but in a second. But this, and then just down here in the Montoya, I just have the Dunham 1962 mudstone and gray up through grainstones here in the little greenish. Yeah, the kind of, when we look at the Fusselman facies here, and I took that out of this deck specifically, but we can go to it if we have time
Oh, I
to look in
see.
more detail. But there's actually, you see a systematic stacking arrangement of features, even though we're overall in the equivalent of the Fasken formation of the Riston group in this upper part, which is dominantly a shellful strata. We actually see a kind of full complement of kind of proximal to moderately distal features here. So this pinks and reds above ramp crest and this is something that was so interesting, right? Because one of the reasons the Fusselman is not studied as much as the Montoya is that the Fusselman has very coarse dolomite crystals. So
Really?
this line here, this is dolomite crystal size, which so I have a little USB
Really?
microscope that plugged into my phone. All of these data sets, by the way, are sampled at either 1 or 2 decimeter sampling intervals. So point 3 to 0.7 feet, which is equivalent to what you'd get in subsurface wireline logs. Um,
Huh.
but this, so yeah, this took a little bit of time to generate this, but you can see the size up to 0.4 millimeters. So that's,
Wow.
you would be talking kind of medium grain sand if at the far end of the scale.
And these are
So
dolomite rhombic cubes, or what? It's hydrothermal then, right? Isn't that a hydrothermal
po
indication?
possibly. So that's an interesting conversation that particularly for this stuff at the top, um, but
Yeah.
definitely. But so you're talking about a couple of mechanisms that are going on here. One thing is that you see there's been some studies, petrographic studies done by the BEG, and I forget the exact reference, but they interpreted that a lot of the dolomite was early, based on cross-cutting relationships to features that you could clearly tell were like saddle late dolomites that have a distinct geometry. And that would be consistent with the fact that we see when you drop down into the Montoya, your crystal size becomes much finer. So it
Hmm.
is tied in some way to the original depositional environment. But
Wow.
where that ties back to why the Montoya is better understood is that the textural preservation of primary sedimentary features is
Oh,
much better in the Montoya because
and the
those crystal
fossil.
sizes are finer.
Hmm.
But when you look at the Fusselman, you can actually still recognize definitive features. The other challenging thing is that you see with this cross section is that it just is thinned by post-depositional erosion so quickly
Is that what's
that,
going on?
as you just go over, this, I mean, this is way out in Alamo Canyon, but just over this 15-mile stretch here, it thins by about half. So you're not getting the full section
The
exposed.
the Montoya to Fusselman contact is the bottom one. You hung it on the top of
Yeah, so
Montoya.
so it's a little bit confusing, but yeah, this one. So I had the one before where it was everything, and then I kind of flipped to zoom in because I have where I was originally going was to explain the facies in here. So when you see these reds, these have pretty diagnostic uh, features in there, despite the fact that it was something that was often mapped at the regional scale back in the day, as though this was massive, massive gray dolostone. There's pretty distinctive features that you see in here. So the pinks and reds, the most distinctive thing that I'm taking that to above ramp crest is that you would have, fine lamina in there. So fine lamina or very thin beds. Sometimes it can be hard to discern the bed boundaries because of the diagenesis, but then you find stylolites, which are present at a much higher density up here. So a lot of the bedding surfaces were stylolitized, or, you know, uh, sometimes you would see hard grounds and stuff like that indicating repeated exposure. So this is stuff that was shallow and was exposed repeatedly. You occasionally see stromatolites and stuff like that too. So you're pretty shallow within the photic zone. Stromatolites are other cryptalgal features.
The cross
And
section in this is kind of going north south as you go from the left side to the
so
right
you're going
side.
southwest to northeast up here.
But the actual line is mostly going north, and then it hops like a hard right over
Right.
to the northeast.
Yeah.
So this
So
thickening to the west, and this is also when we get the west directed Acadian, right, antler orogeny, because that's what's happening after Montoya.
yeah, so the thickening, yeah, so this is mainly it's a thinning to if we go back to the thickness contours, it's it's thickening, yeah, to the south, and then definitely thickening into the Tobosa Basin, to the east,
I
and then
see.
thinning to the north in
Yeah.
all directions, and you get yeah, when this stuff gets uplifted up here, right, you have a pretty pronounced knife edge where that it just kind of goes away.
Okay.
So yeah, you're becoming more generally more proximal, or at least more post-depositional erosion as you go up here.
Okay.
Because the Alamo Canyon section is off axis, your actual facies may be a little bit more distal because you're closer to the Tobosa Basin there,
Okay.
but you're definitely getting more post-depositional erosion as you go up this way. Of course, I would love to have more measured sections along the San Andres Mountains, but of course that's in the Bliss, uh, the Bliss artillery range and the different missile ranges up there.
Oh, is
So
that right?
yeah, so Dr. Pope, when he did his work, and it took, he was doing work over many years, but he actually measured almost every one of these canyons up in here. But you have to go through the government and get your work reviewed and get official permission to
Let's do it. Let's file
share
that
it. So
paperwork, man. We
yeah,
gotta we
man.
gotta go back.
Yeah, well, yeah, if I didn't have a full-time job, it'd be great. But yeah, so I was mostly hitting places, public land that I could easily
Yeah,
go into in the middle of the night after a
right.
full week of work without arousing arousing suspicion. So yeah, these are all on public land. But yeah, but anyway, yeah. So yeah, you see these, and then when you go the blues, when you get into the ramp crest and below, you see open marine fauna. So brachiopods, you're often seeing a more restricted fauna up here. When you get down to the blues, you see more open marine fauna, and then you get down to the dark blues where you see nodular chert. So
Modular
you're
shirt.
getting down, you're getting down maybe closer to the massive mudstone with occasional nodular chert, where you're kind of going down into the middle to medial to distal ramp setting, where you're probably getting a little bit of upwelling and some nutrients coming down. Nowhere near the amount of chert that you get, of course, in the middle of the Alaman and the Montoya, which is up to 60 to 70% chert. But
Whoa.
yeah, that's so yeah. Anyway, this is so, but of course it's pretty obvious from this. Overall, the Montoya is a shallowing upward, or the Fusselman is a shallowing upward succession at the 1,000-foot scale or hundreds of foot scale. That's not anything new that had been written about before. But and then you could start taking a stab at pegging out uh, some of these higher finer scale cyclicity within there, where you get little shallowing upward successions in there. But that just due to the amount of diagenesis and the scarcity of the outcrops, right? It's kind of in the rapid change that's happening. Because what also appears to be happening is you're shallowing northward, right? At least here. So you start to lose your open marine facies as you go up to the north.
Okay.
Um, but a very interesting thing about the crystal size variation, right, is you have these apparently cyclic changes in crystal size, which possibly could be mapped. I have another measured section that I don't have on here that I'm currently compiling right now, but it's possible that these reflect local exposure surfaces where there was more diagenesis along the early diagenesis, early seepage reflux or brine density
Yeah.
dolomitization along those surfaces, which led to the coarser dolomite crystals. And by the way,
Could
going back to
be.
our original thought, that's the thought for why the Fusselman overall has much coarser crystals than the Montoya, because the Montoya is thought to be more of a cool water carbonate. You see a lot more
Huh.
chert in it, indicating more of that upwelling activity. Um, Whereas the Fusselman's thought to be deposited in more of a warm water
Warm.
carbonate with net evaporative conditions. So
So
that would have
those
led to, potential brine density type dolomitization early on, and particularly in the ramp crest and above
the
stuff.
cycles could be hydrothermal plumes coming from deeper structures, right? You could get hot brines coming from the deep and in cycles, right? And some
Yeah,
kind of
potentially it
structural
would be
event.
interesting to see but there is a somewhat of a strong. I said I don't want to speculate too much about it because it's early data. Now,
Yeah.
what I would say is this stuff up here is wild, and this highly coarsely crystalline dolomite at the top, this so yeah, this I mean, right, this is almost
Yeah.
certainly burial. You see the geometry of the crystals up there is a little bit different than what you
Uh,
see in the versus the well-formed ROMs down here. So
uh,
it's and so this is one of these interesting features, okay, that we saw things like this in the subsurface and we didn't know what
okay.
they were, right?
Okay.
Because you see coarsely crystalline dollostones interbedded with preserved limestone, right? So the limestone is unaltered. The limestone's the original rock, right? It's all originally deposited as
Like
limestone.
massive lime, like no fossils, nothing, just
No,
it's got a bunch
so
of fossils.
yeah, it actually has, yeah, where the limestone is present, you've got some of the original textures and features in there. So you can see if you thin section it, there's peloids and stuff.
Oh, there is. Okay.
Yeah. So there's fossils and stuff, and a few of these are the particularly here where these light pinks are. These are things where I found some macrofossils. Um, so yeah,
Higher
there's
energy.
still some living critters in that preserved limestone, and then you get into the dolostone, and where it's anomalous compared to the rest of the section. It's much more coarsely crystalline, and
Wow.
we saw these things, and we had a couple of hypotheses, right? We thought they might be, you know, carbonate mounds because this is the part of the section that's equivalent to the Riston group, and there are documented bioermal buildups in the Riston group and the subsurface that produce oil. We also thought they might be cavern fill because you have that analog to Dollarhide field where there's a cavern system that where the pore system is within the collapse fill of the cavern. But then actually seeing it in outcrop, yeah, so that's the Montoya. This, so this is what I'm talking about when I'm talking about these facies, right? So you have open marine fauna here, and this is the ramp crest facies. It's one of the few things in the Montoya that if you find a piece of it on the trail, you know exactly where it came from, because or not the Montoya, in the Fusselman. The Montoya, you find pieces of it, you know exactly which of the formations it came from. The Fusselman has been historically more challenging because there's a lot of overlap in these three lithostratigraphic members
What's
in
up
there.
with the crack? A crack up the middle of that.
Oh yeah, so that's right. So there's a lot of fractures. But this is also right. I mean, it's just really weathered, right? So, um, but that this is zoomed in, and this is my Jacob staff with
Nice.
obviously made from a PVC pipe, but these are one decimeter intervals on here, so that's the scale you're looking at. So yeah, and the outcrop, it's hard to distinguish what's a tectonic fracture from what's just a unloading or like weathering feature where some of the finer grain rock will get washed out, right, and then the rock kind
Yeah.
of tilts a
What
little
do you
bit.
think that white material is that's along the fracture face on some of that? White material on the crack. You see that?
Yeah, so there's calcite that comes from, so you have limestone rocks near this, so there's a lot of preserved limestone in the Ellenberger group and the overlying Mississippian stuff, and so you get these soils that form, and so this is, I forget the exact, but it's similar to caliche forming. Basically, you'll get where you
Whoa.
have groundwater flowing at the surface, and it's so arid out there in the desert that little bit of limestone that's in the groundwater or in the rainwater, when it comes through there, will
Precipitates out.
evaporate. And so this stuff will be, yes, this whole thing is dolomite, but that white stuff will be explosive when you hit it with acid. So it's little caliche forming on there. So so then you get all these brachiopods. This is in non-growth positions. So this is our high energy ramp crest facies. You go a little bit down from it, right? You still have your open marine fauna, your brachiopod molds in there. So there was open marine fauna here, but there's not as many of them, right? So that you're getting, and this rock is darker in color, so you're getting more
Yeah,
of your
way
distal.
darker.
Yeah, and then
Wow.
here, you get your more distal settings where you have these chert nodules. There's no macro critters in this stuff, right? And then you
Wow.
bang off the surface, and it's kind of dark underneath, so it oxidizes when it weathers. So this is, so that's your proximal to distal of your ramp crest and below. When you look at the above ramp crest, yeah, you get a lot of vugging. It's much lighter in color, as you can see, and and then you get these laminous surfaces, which are often hard grounded or stylolatized.
Wow.
Um,
How about that? Look
there's
at these cracks.
mhm.
Wow.
Yeah. So again, you're looking at a lot of, right. You're looking at probably a couple features that are right. You've got a soil forming under here and plants growing up on it. So this may
Sure.
be not perfectly in situ. It's kind of tipped off the front of the outcrop a bit.
How about this stromatolite one? That's along a fracture, huh? That's a fracture plane that thing's sitting in front of? That stromatolite?
I would, so the fractures in the fractures that we see in the subsurface are more commonly the, the vertical ones.
Okay.
So they're, so these may be actually original bedding planes here.
Ah,
Or so, uh, yeah, but you see, stromatolite or maybe more correctly, a cryptalgal type of structure. And I have better pictures of these in another deck somewhere, but yeah, you find these uh, around, and of course you've got at this scale, it's kind of hard to see, but some of these little dots here are little shells, so
man,
little
look at
critters,
that.
So
That
yeah, it's
middle one, this
yeah.
abundant vugs, the
Hmm.
abundant vugs, the stylized laminated surfaces. I mean, you can almost connect all that with a lot of those fractures, the vertical ones, and then it goes horizontal down one of those surfaces. I mean, it keeps going vertical at the top of the
Yeah, there's
image.
definitely a lot of, I mean, right, this stuff in outcrop has been messed up a lot. The fracture density that you see in the outcrop, um, generally for subsurface strata in the Permian Basin, it's about an order of magnitude higher fracture density that you observe in outcrop than on subsurface image logs. Um, so, yeah, you've got that combination of tectonics and the kind of weathering and unloading fixture. So yeah, I mean, potentially. But when we get to the dolomite at the top, that's the thing that's definitely, this stuff, the thing about this is pretty homogeneously dolomitized.
Okay.
So you're not, within this part of the outcrop, which is, uh, this section here, you've got a lot that's dolomitized. What strikes me is and so that definitely it has something to do with the original depositional facies, particularly considering just how uh, in the time for this presentation, I haven't had time to measure all the crystals or to run the crystal size analysis on the Montoya photos, but I did it for a little bit of the top Montoya here, and you can see it's about an order of magnitude lower crystal size just once you
Wow.
cross that unconformity. Um,
Mm-hmm.
so most of that, again, the main hypothesis is that most of the homogeneous dolomitization is happening, or at least it's getting started early on. But when we talk about
Mm-hmm.
this stuff, this is a distinct breed of dolomitization, and this is wild. So this is, hydrothermal is definitely a strong hypothesis for how some of this may have formed. Of course, you're on the far west Delaware Basin here. Um, so, there could be, you're near obviously the west side of the Delaware Basin, a lot of igneous activity, a lot of
Sure.
hydrothermal activity, which we see in the later part of the trip when we look at the Fusselman hosted fluorite deposits. But yeah, I mean, this is this is pretty crazy, right? But this was really cool because it pretty much exactly mirrored what we had seen. So here's a real log from the subsurface in the Delaware Basin, and then here's
Okay.
my outcrop log at the same scale. And so what we've got here, this is rock hardness derived from unconfined compressive strength, or derived from the sonic log, right?
Okay.
Um, so it's analogous to my rebound hammer hardness here. And then you have photoelectric log here, which is analogous to that reactivity with dilute HCl, so flagging the preserved limestone interval shaded in blue.
Right on.
And then enrichment of uranium in that
Ah.
dolomite that happens right below the intervals of preserved. So yeah, that's burial, some probably hydrothermal, but again, um I'd want to work with some of the stable isotope folks to
Yeah.
um
Send it
before I
in.
make a strong statement that could be disproven later about that. But yeah, but it was so cool to see that, to get that, because that was one of the things we looked at that and it was like, oh, it's so cool. But like, what is that? And
Yeah.
we didn't know because we didn't have good analogs for it. And so and that's just why it was so valuable to get out in the field
Look at
and
that.
look at the rocks, and at least we know what it is, and we can start coming up with different models like you're talking about, like hydrothermal, and then you start thinking about, well, what does that mean for connectivity? What does that mean for
Oh
how
man.
much pore volume do I have in place, right? If it's hydrothermal versus early dolomite, right? And so you
Right.
get, yeah, so this is so these are from the type section of the Northern Franklins. These are from Anthony's Nose, which is a little bit easier to get to. So we'll go here on the field trip. But this is pretty cool because you kind of caught it in the act. So here you've got like a pure or nearly pure dolomite phase, and then little bits of it are intruding
Yeah.
into the limestone. But here, like you're very clearly like you're catching it, this is like maybe 10 or 25% dolomitized, and you just see the well-formed rhombs coming out of the limestone matrix, and of course some original uh, you know, critter remains around there. So that kind of alter the path of those fluids that move through post. So that, that's very clearly a burial situation.
What do you think that black speck is in the limestone in the dolomites in the bottom right?
That's lichen. So
It's biology.
yeah. So that was actually a little bit of an annoying issue when, unless you like really bleach these things off, they got little living critters on them. And so, and so when you look at the grayscale color log, I actually had so this is which I made this because again, you saw those different parts of the outcrop were very different colors, or at least lightness, darkness, right? So,
Yeah.
but I had to threshold out the lichen on these. So you get these little black lichens that grow on there and in fact, some of the things that are mapped it's one of the reasons you have to be kind of cautious with the color here, of the weathered rocks on non-clean surfaces, because they'll either get that oxidation and or the living critters on
Wow.
there. So yeah, these are lichens, and they'll, if you clean it with acid or bleach, they'll go away.
That bottom left image, man, it looks like an injectite from a hydrothermal thing. That dolomite just injecting itself into that limestone.
It's definitely my mental model is that this is maybe a bed boundary with, and then you had enhanced fluid flow
Oh
along
yeah.
that
High
permeability
pressure.
conduit.
High
Um,
pressure, hot, full of magnesium.
yeah, so that's a possibility, right? So, but anyway, this is, these are really fun. So this is a cool thing to see. And like I said, we could
Heck
speculate to
yeah.
all end out, but
Yeah.
I'm definitely hoping, getting this stuff out there just gets, this is a real easy, this is a layup project for, a grad student or
Yeah.
somebody who's,
Yeah.
working on stable isotopes and carbonates or other types of geochemistry to investigate,
Yeah.
get some thin sections and do some, some CL and some different, some sequence analysis on when these different features formed. Um, that's definitely would be a very interesting project, and it's low hanging fruit now that we've kind of remeasured these, and I can definitely help somebody, anybody write up a value proposition now that we know how it relates to the subsurface. So,
Awesome, man. Wow. That's awesome. I'm excited for this. I'm excited. I
oh yeah,
don't
this stuff makes my hair stand up on end. It's so fun. So let's look in the last couple minutes here at I'll put back up the other deck, and this, the first time, so this was the first like field trip that we've offered a similar trip before at WTGS. So that one was like the first solo field trip that I'd like solo led, you know. Um, so so I was a little bit nervous, putting this together. It's like, am I going to do okay? All this, but then I found when I was out there back in 2020, originally just walking around, then I found Bishop Cap, and I was like, dang, I don't even have to try on this one. I can just like show people this. I can just take people here, and it'll be cool. So yeah, so this is the northern extension of the Franklin Mountains. So this is a outcrop called Bishop Cap. This is from the Seeger 1973 geologic map of the area. And if you go back to our map where we are, we're right here.
Oh,
So
wow.
remember, so this little lump right here is the Organ Mountains, right? So this
Okay.
is, you know, igneous extrusive and shallow intrusive stuff. So you're right next to all the igneous rock right here. Okay.
Wow.
And there's this boundary fault that runs along here. There's at least 3,000 feet of relief between if you're standing right here and when you're standing right here. So when you go back so this is tertiary igneous stuff, and
Okay.
this is Paleozoic. That's just the extension of this
Wow.
Franklin Mountains fault block up here.
Holy
Okay.
smokes.
So it dives below the subsurface and then it pops back up. And so you have your
Wow.
same stratigraphy that you have in the Franklins. And
Okay.
again, you're looking at right here, but it's thinned, but it's long and it's about 11 miles to the north. Okay.
Okay.
So, and of course I measured that section in here somewhere. Yeah, okay.
Okay.
So this area is really cool. So because again, there's a fault that runs through this alluvium covered area right here, and then you've got at least 3,000 feet of igneous extrusive and shallow intrusive rocks over here. So a lot of relief. But anyway, these, and then this, right, overall, the Franklin Mountains, we didn't really talk about this earlier, but overall, right, the Franklin Mountains is a horsed block, right? So you have you have your, going back to the map, right, you have your Hueco Bolson, your Tularosa Basin over here. So this is a big graben,
Right.
right? And then this is your Horst running along here. Okay.
Okay.
And so the whole thing in the Laramide, when you get in the late Cretaceous, the whole area is uplifted several thousand feet. And then and then you have your whole story with the
Basin and range.
with the Farallon plate and flat slab to sinking slab subduction, and
Yeah.
so your basin and range your extension starts happening, and so then you whole thing's uplifted and then pieces of it get dropped down, and so then you're left with these sheer faces, right? This eastern side of the Franklin Mountains is a normal fault face. So you've got strata that are dipping at about 45 degrees, which is excellent for measuring section zone.
And
Um,
the
they're
dips
to the
obviously going
west. It dips
it's
to
dipped to the west.
Yeah, so it dips. So it dips. So if this is east, this is west, and the measured sections are on the east side. So let's look again at the WTGS cross section. So this is your, so it dips to the west. The faces are exposed on the east. Okay, so that's
The
you
east
have.
is dropping down into your basin.
Mhm.
Okay. And
Yeah. So that's your overall scheme. Same basic thing that's happening at Bishop Cap. It's just the northern extension of that big horse running along here.
okay.
And it just gets covered by surface material for a bit. So yeah. So what's cool about this area is because it is right next to the Oregon batholith and all of that associated igneous activity, it was faulted up and hydrothermally altered a lot more than the stuff that we see to the south and in the basin. So this stuff is, rather than being one main fault block like the Franklin's proper, it's dissected into these little like subhorsts. And each of
Whoa.
these is like a steeply dipping face and then a gently dipping back. Each of these little
Really
canyons in here.
asymmetric deal.
Yeah, asymmetric. And so and of course, those are great. This is a favorite shooting gallery for the locals. So they like to, when you get this blue star fault that runs along here, so you have these subhorst which form your little valleys, and then you have a ridge that's along this fault that you can stand
Whoa.
on, and so you locals like to go out there and shoot things. So you'll make some friends. You know, I think it's technically part of a national monument. So like but
Well, outlaws,
it looks
man.
and smells just like ordinary BLM land. So you'll find empty cases of Dos Equis and Mick
Yeah, yeah.
Ultra and stuff lying around, and it's the weekend,
Pick up your
fresh
freaking
donuts
trash.
from people on their side by sides driving around like on the gravel Jeep trails. So
Ay, ay,
anyway,
ay.
this area, because it was adjacent to the Oregon batholith, there was usually sub-economic, but nevertheless significant quantities of sparry fluorite deposited along these fault surfaces. So this map right here is
Whoa.
zoomed in on this red square. And again, looking at Seeger's map, and then I've traced these white solid lines are tunnels. These were dug by the U.S. Bureau of Mines,
Wow.
what was then called that in the 1940s during World War II,
Wow.
when the government was trying to subsidize domestic mineral generation and extraction. And over the years, there were multiple people tried to file claims out here. There were several exploratory holes, cores taken, drilled, But generally it was beside a few truckloads of sparry fluorite that they took away, nothing economic was ever found.
Wow. Wow.
So it's now part of the, like I said, it's now roped into part of the Organ Mountains National Monument. And so it's off limits for future economic activity. But these tunnels are still open. They go back, you can see the spatial scale in here. They only go back about 30 feet. But what's cool is the mineralization happens along these faults.
Yeah.
You can go up, and one thing we'll do is it's awesome. It's like having 3D seismic and looking at a depth slice. We'll go up and stand on one of these hills and look at our topo map, and we can trace the faults because they're silicified, and so they weather out from the surrounding dolomite.
Wow.
So this, of course, these symbols here, the um, Pennsylvanian Magdalena
Oh, it's
group,
Pennsylvania. Okay.
and then the SF, so the Silurian Fusselman.
Solarian.
Uh,
Okay.
so you've got, so what's cool here is that you have normal faulting that juxtaposes the Fusselman against the Magdalena group, which is very similar to a lot of our Mississippi and lime strata and
Oh,
subsurface. So, and then this fault rather here, so there's three main generations of faulting here. There's a couple of theses that look at this. So they're out on this side, there's actually some reverse faulting and some folds, like this reverse fault right here. These are thought to be associated with laramide orogeny. So they are cut by the normal faults in a few places. So the
okay.
reverse faults happen first. Then you have these two generations of normal faulting. You have the north-south normal faulting, which is consistent with the regional basin and range. And then you
Tertiary
also,
stuff.
yeah, extension. And then you also have this like blue star fault with the east-west running normal faulting. And both of those generations, this is thought to probably be a more local, the east-west normal faulting is probably a more local feature associated with the intrusion of the and uplift, local expansion and uplift with all those
Yeah.
igneous things coming in right there, right?
Okay. Kind of
Whereas
has
this
that
is,
shape to an intrusion too, the way it's kind of
mhm.
edging something around.
Yeah, at least
Okay.
the way it's interpreted on there, that the cuspate is part of the same fault. Walking around it in the field, you kind of be like, well, does this, there's that, right, there's another, like, there's a fault that continues right across here too. So you're like, well, I could draw this way as well. But they
Yeah.
called this the Blue Star fault. The Blue Star deposit was up here. And then you have the Fusselman outlier prospect, which is right there, which is Fusselman on Fusselman action. So, uh, so anyway, I spent a few weekends down in these tunnels mapping fracture orientations and stuff. So it's pretty cool, and you get to see, there's each tunnel
Sage,
has
look at that.
different colors of fluoride in it. So they're again, remind people this is technically a national monument, so like, leave it for the future geologists, but nevertheless, you'll find people selling it, advertising that it's from this location online. But yeah, so you've got purple, you've got aqua. I didn't have a good picture of the real dark purple in here, but you see that in some places. And then the barite, or these long platy crystals here. So, make some drilling mud.
Yeah,
Uh,
that's right.
uh,
Don't say that, man. Careful. You're going to give some people the bad ideas.
but but yeah, you've got, so this is actually a drawing from the 1946 US government publication on the orientation of this tunnel number 2 here. What's amazing about this is, like I said, these tunnels, so right, you could see the tunnels you could see the faults at the surface because they're silicified, okay? And then what they would do is they would then go down the hill and dig a tunnel to try to intersect the fault, okay?
Yeah.
So then you also had these hashed lines here. These are surface adits. So these are
Oh,
just
wow.
trenches that they dug at the surface,
Wow.
okay? And versus the solid lines of the actual underground. So this is one of these tunnels. So you've got a few feet there of, a few tens of feet of actual mineralized stuff. So I spent a Saturday in that tunnel measuring fracture orientations and hardness along the rock. So this is a plot of just fracture density as you're walking through walking through the rock, and then of course the fracture slash vein aperture. What's really cool is you see those different generations of fracturing in here. And the amazing thing, again, they would tunnel back, hit the fault, and then go along the fault for a little bit. And so because you curve at a right angle, you can see the cross-cutting relationships of the different fracture sets in 3D.
Man,
So you
right
can
on.
definitively assign relative age relationships. So within this tunnel, there's a composite photos going through the tunnel. There's your big fault surface right there. There's a fault breccia zone there. You've got this ore vein that's about 10 feet.
Okay, so this
Unfortunately,
is flipped. So when the last image you're showing us the fault on the left side of the image, and
yes,
now
that's correct. Yeah, sorry.
okay,
So I'm on the south. I'm on the north wall. Yeah, I guess I'm taking photos on the north wall, from the
okay,
north wall, looking at the south wall.
okay,
So this is, sorry, that's reversed. So this is the outside, this is daylight coming in right here. And then you have these different, of course, you get discrete fracture swarms, a lot of
look at
interesting
that.
behavior. This is all Magdalena group right here. And then this is Fusselman underneath the fault
Awesome.
right there. Yeah, the Magdalena group is crazy. This is a highly interbedded Cherty limestone. It's very hard. And so it fractures, spectacularly. The fracture density within the Magdalena group is significantly higher than the fracture density within the Fusselman. So I measured, these are fracture aperture measurements here. So the Fusselman in light blue, the Magdalena group in dark blue. So you get the much bigger fractures happening in the Magdalena group, the wider aperture veining and stuff like that that's happening in the Magdalena group because it's more brittle, and of course that coincides with it being much harder.
Yeah.
Uh, right. So of course when you plot all these up, you get two dominant fracture orientations. So you have your north-south oriented fractures, and then your east-west oriented fracture set, and possibly some subordinate sets. But
So
right,
you're
you're
saying that's the direction that tension's going, like tension is in
so
the
this is the strike of the fracture plane.
strike of the fracture plane. So
So these
the
are opening mode fractures, or mode 1 fractures. So they're perpendicular to minimum stress. So extension is happening
okay.
so if the line is north-south,
Yep.
then extension is happening to the east and west
Got it.
perpendicular of that. So
Got it.
what's cool about this, of course, is this is, despite the fact that it's locally anomalous and much more spectacular, than much crazier stuff than we see in the basin, because you're just so much closer to the igneous activity here.
Yeah.
And it does have that local igneous overprint. But this is still, if you look at another Chevron geologist, Dave Forand, who published a paper on the subsurface fracture orientations in the Permian Basin a few years ago that was then picked up by Mark Zoback, and was the primary source of the subsurface image log data that on Zoback's paper on stress state in the Permian Basin. They see the same thing in the Permian Basin subsurface, where you have these two nearly orthogonal fracture sets, right? So like it's in a loose way, very loosely speaking, an analog for the subsurface, and that these fracture sets are likely due to the same orogenies. So the east-west fracture set likely reflects, and then the dots on here are the poles so the poles are opposite of so for the north-south striking fractures, the poles to the planes are lined up like this, right? And
Doing the
and then
perpendicular
the
thing.
dots are shaded by the size of the vein fill. And what's interesting, right, is so your north-south fractures are the ones that get activated and filled with hydrothermal fluid, because that's aligned with stress in the tertiary when all the igneous intrusions are happening, right? So what's happening between the Laramide and the late Cretaceous, you're right there, you're getting compressed from the east-west. So your minimum stress is to the north and south. So your fractures open to the north and south, and that's what
Okay.
generated this east-west oriented set, okay? Almost all of these are hairline. They're almost
Wow.
always very thin, because there wasn't local igneous activity then. But when the hydrothermal stuff comes in, and the stress at that point is um, contemporaneous with the basin and range. So now you're extending from the
Yeah.
east and west. So you're forming north-south fractures, and
Yeah.
those fractures start filling with that fluorite material as the hydrothermal fluids rush through it or come through it. So, so yeah, so that's it's really cool. And like I said, a very coarse scale. And we see a few places, and you can tell by cross-cutting relationships within the tunnels that the north-south sets will offset or truncate into the east-west sets. So the
Mm,
east-west set formed first, but despite being there, there's hardly any mineralization in that set
wow.
because it was perpendicular. It didn't want to open up, you know.
Yeah.
So that
Yeah.
so
So
that
it didn't, the younger stuff didn't use the older paths, the older fractures, or it did?
it
To
didn't. So
it didn't.
it ignored the older fractures and went with the younger fracture set
Whoa.
because that was aligned with stress at the time that the hydrothermal action was happening.
Did wow. Yeah. Usually okay. Wow.
So it was just easiest for when those fluids were coming through, right? It's easiest to push if this is minimum stress, it's easiest to push in that direction rather than pushing in maximum stresses direction.
Yeah. Yeah.
Now, if
Yeah.
you hadn't had this nice set of fractures that was being generated with the basin range, they probably would have reactivated,
Right.
you know, these that would have gone somewhere, you know.
Yeah. The fluorite would have been
Yeah.
in different orientations.
But
Wow.
yeah, but the Fusselman in general doesn't fracture, does not have as spectacular of fractures in it as the Magdalena group does, you know. But
Whoa.
you know, of course, we're not either you know, this is a very tight rock, so we're not producing oil from it or disposing water into it anywhere. So unfortunately, didn't get to spend as much time with this. There is a lot of interest in this. Some recent publications just looking at the stratigraphy of the Pennsylvanian and Mississippian sections here because they are analogous for sort of carbonate basin floor sedimentation, you know, which is important in some parts of the Wolfcamp and Bone Spring. So, but that's a,
Mm.
you know, different groups of people looking at that. But yeah, that those are real fun rocks. So, anyway, that, you know, beautiful. Pick your favorite crystal and decide
Sheesh.
which each tunnel has a unique crystal. We also, we didn't even get to talk about the yeah, for coming on this, we have this, and then we also have one tunnel where everything's black because it was a meth lab and it blew up. But like
No.
that's at least that's what we've surmised. You know, we when we found the like you
Oh
know, like
my
the gallon
goodness.
jugs of bleach and like the chemical goggles and electrical cords with
I
open
can't even.
wires coming out of the ends in the back,
Oh my
and the whole
gosh.
thing is covered with soot.
Yeah, yeah. No skeleton bones.
No skeletons. There's a burned out mattress in the front of it. And again, this is
Oh my
your beautiful
gosh.
national monument. Do not disturb the
Ah.
rocks. But
What do they call that now? The Anthropocene or something? They're
yeah,
it's just,
but yeah, if you scrape off this, actually the aqua is actually in the perhaps coincidentally, it's like they picked the blue crystal tunnel to do their meth in, but the but it has but this is a part where that was not, but yeah, just you can see off here this black. It's like
yeah.
all covered with soot, the whole thing, and it kind of smells dirty and junk. But that was a yeah. So far as we can tell, I've been going out there for 4 years, so I don't know when that happened, but it was before I ever came out there. But you know, well, that's our fantasy explanation for what it is. But at least something blew up and burned, and there's a lot
Yeah.
of plastic plastic chemical jugs and
Now someone
electrical
may have went out,
paraphernalia back
right.
there.
Someone may have just wanted to try to blow it up, see if they can find any bigger crystals and stuff. You know, it could have been a mining operation.
Yeah, the plastic chemical goggles kind of gave us.
Yeah, that's true. Yeah, there's some more evidence
But
there.
yeah, it is a more recent feature than any of the actual mining that happened. But they you know, you can see in the backs of some of these there's core holes where they had drilled and excavated. But yeah, it's just amazing thinking about some of how sketchy some of these roads are that they got those old you know, old 1940s trucks up the road to, you know, and like most of the tunneling was done not by explosives, you know, most of it was done by manual
Hey,
slash maybe hydraulic, you know, assistance. But
yeah.
you know, it's a different time,
Man, well, this is cool. This is cool. I appreciate all the work you put into this. I'll be doing the core workshop on Thursday, so if possible, maybe I can pay the full price and just meet up with you guys on Friday. Is that possible?
Yeah, yeah. Um,
Okay,
yeah, 100%. So we are staying in Las Cruces.
got
Um,
it.
so that's our base, and we'll be leaving out in the morning to go drive up McKelligon Canyon Road. So we'll leave Thursday afternoon, and I have to talk with the participants about exactly when we want to leave. I
Okay,
am excited about a lot of those cores, although I'm probably going to get to see some of the Woodford cores of a separate thing with the BEG. So, but but uh, the transition zone stuff and the kind of Montoya Simpson interval was definitely very, same time as this, so it was very interesting. So
yeah.
we'll just kind of arrange as a participant group. We had because of one of our participants last year, we had access to a Thursday afternoon stop that was along the way.
Hmm.
We don't have that this year, so we'll just be going like straight to, leaving straight from Midland. We'll eat dinner in West El Paso, this little taco bar place, and then shoot up to
Nice,
Las Cruces and
nice.
stay in the hotel. So
Yeah, so maybe what, 5 hour drive, something like
yeah,
six
if you do
hour?
it straight, you can do it in, yeah, a little less than 5 hours. So
Yeah.
yeah.
Okay. Nice. So you guys will be up there by Thursday evening, and then first thing Friday morning you're taking off
Hmm.
and hitting the first set of stops. Okay.
Yep.
And you're coming back Sunday,
Yeah, Sunday afternoon.
Sunday afternoon. So
Well, Sunday we'll be back Sunday evening probably. It's going to be now
okay.
again, if you had to leave, but this is, let's see. What we'll do is, because we're going to do a big loop, so we'll come in from the south
Yep.
and we'll go up here to Las Cruces just because that we want to have one base camp. But then we'll
Yep.
go down on Friday. We'll go hopefully an hour in and out to McKelligon Canyon Road. Then we'll
Yep.
go up here, do a short hike up to the cave on the north side of the Franklin, see the whole other thing we didn't even talk about was the Peretra Shale, which is the Woodford of
Oh,
the
yeah.
subsurface.
Yeah. Yeah.
So we get to see a transition from, it is very locally variable here, going from more anoxic to more
Oxy.
oxygenated
Huh.
deposits. And so we'll see some kind of dysoxic
Interesting.
gray shale percha right here. Then see the karstified Fusselman. Um, and then, have lunch and then scoot up to North Anthony's Nose and walk up the whole section of the Fusselman and Montoya there.
Nice.
Um, so that'll be
Friday, basically.
Friday, and then Saturday will be at Bishop Cap.
Got it.
So that's Saturday is all day at Bishop Cap. There's a ton of
Okay.
stuff to see. And then Sunday we'll loop around back over the Tularosa
Oh
Basin,
man.
drive past all the missile ranges,
Oh
do a quick
man.
hike into Alamo Canyon where we can see the truncated section and orange oxidized Peretra. So a much more proximal
Whoa.
setting, touch all the unconformities. So we'll trace the unconformities for 60 miles, and then go up the backside of the Sacramentos, eat lunch in Cloudcroft, and
Right on.
cool down a little bit, and then drive back to Midland.
Right on. Sir, well done. Well done. Your time of your own personal time and attention on the rocks. I'm so happy I got to meet you. You are a true geologist. You're part of the true crew, and turning this into an event that allows people to come out and see this and better understand the fractured complexity, the tectonics. Combining all this stuff with new hydrothermal ideas. Like, I mean, what an interesting and fabulous field trip that you've put together, man. I hope to join you guys on Friday. Like I said, we'll see if it works out. But if people can get signed up now, what do they need to do? Just go to the website and
Yeah, so
and
go to WTGS.org. And if you click on the calendar of events, they may have to check if it may be on the actual front page now, but if you go to the calendar of events and you click on the field trip, um, that it, that will show up on that weekend, and it'll take you directly to a registration page.
perfect. Okay. So website, go to the website, calendar events, find what is this? The 21st, I guess, is what you're looking for, is when it starts, or the 22nd.
Yeah, so it will
Oh,
go.
let's just do it. Let's do it. Share your screen. Let's do it.
Yeah, let's do it right here. WTGS.org.
Oh
Um,
man, that's the Glass Mountain trip. There's
yeah,
me.
dude.
There's
That
me. I was on that one, man.
nice. Yeah, this was, man, they used to get such big crowds for this. This, there's Pat and
Oh
man,
yeah,
all the crew. It's like we've struggled particularly after COVID to get this many people together again. But
yeah.
if you go to so this is just WTGS.org, click on events, and then WTGS Fall Field Trip right here,
Bang,
and there's your registration information.
boom.
So uh,
Generously, always sponsored by Suttles, man. Those guys always come out. They love the field trip part of this. They love sponsoring the field trip every year. It seems like at the
they do.
WTGS.
So they are, yeah, shuttles are amazing. They send two attendees with us. So they'll bring drinks. So we'll have refreshments and
Yep,
alcoholic beverages.
plenty of bubbly,
Nice
plenty of
beer at
seat.
the end of the Bishop Cap Day is always tasty. So it looks like, because yeah, we're close. So they're saying registration is closed on here, but it's
Oh,
not like it's
okay,
so if if this, yeah, this is the flyer, but go
okay,
to if you email WTGS at WTGS.org
okay.
and ask to register on the field trip,
Cool,
that will, yeah, we'll set it up.
cool. Right on, man. Thank you so much. You go by Andrew or Andy?
Andy usually.
Andy. Right on, Andy. Well, I look forward to meeting you in person at the WTGS event. And man, heck of a field trip. Thank you for taking the time today, sharing the kind of your journey, getting to this point, finally getting the opportunity to get out there and do this field trip after the COVID fiasco in 2020. Man, good luck with everything.
Always a good idea to look at the rocks before you spend $1 billion on something. So,
Well said. Well said. Thank you, sir.
all righty, see you.